Great. So now I'm going to try and share my screen. Hopefully this will all work fine. Right, can everybody see this? Can someone say yes or give me a thumbs up or something?
Yes.
Excellent. Right, so welcome to SHERPA, and as I said, this is really a user consultation for this concept. I should also point out that today is International Women's Day. I hope that the workshop has not clashed with any other activities that you may have wanted to go. In fact, we have an ISIS activity going on that some of us cannot go to, but it's just a matter of getting people's calendars. So I hope that if you've chosen to come here, thank you. So just to put a bit of background, before I do that, I wanted to introduce you to the SHERPA team, really. So this is obviously a collaborative project. Ian Silverwood, who has been writing you some emails, is the IRIS main responsible. So this is our workhorse Quen's backscattering instrument at ISIS. And in fact, he's the SHERPA scientific lead. So he's the scientific lead for this project. Unfortunately, he had a personal emergency and he couldn't be with us today. Then we have Kirill Nemkovsky, who is a polarization scientist. So he knows a lot of the technical details of polarization. Joran Nielsen, who's the head of the polarization group, and will be talking after me. Then Adrian Pershon is an instrument scientist in the molecular spectroscopy group, which I head, and basically he's our instrument design expert. We've got Rob Bewley, who's the head of the neutron muon development group, who leads now and coordinates the instrument developers within ISIS. And then me, if you don't know me, I'm the head of the molecular spectroscopy group at ISIS, and I've been working on backscattering instruments for quite a long time. So a little bit of history of QUENS and polarization analysis at ISIS. So QUENS, quasi-elastic neutron scattering, started a long time ago, basically at the beginning of ISIS. So the idea apparently came up in 1976 for spallation source. In 1984, ISIS came online, so first neutrons. And actually IRIS, which was the first instrument, QUEN's instrument was built, and it took its first spectrum in 1998. I see Colin is on the call. Do shout if I make any mistakes, of course. Then in 1992, the use of mica. So IRIS uses a paralytic graphite analyzer. And then to get to better resolution, sort of the order of 1 microeV to be comparable with what was achievable at reactor sources, the use of mica was demonstrated. And so then the timeline sort of took 2 paths. So the top path is essentially the path that IRIS, the original instrument, took. So now IRIS is essentially the workhorse QUEN's instrument at ISIS. And next year it will be 35 years since its construction. And so because of that, in a sense, it's quite old. And so we're thinking a little bit about what the future may be for IRIS. And in the past, we've had some thoughts about what this could be, what the user community could want. So we've been thinking, you know, do we fill it with PG on the other side instead of using mica? Would we change the analyzer and build sort of an iron 13 type machine, so high Q, or would we do something different with polarization? And this is, in a sense, what gave rise to start thinking a little bit more about SHERPA. The other side of this timeline is, of course, OSIRIS, which is the sister instrument to IRIS, and it shares the main port, in fact. And OSIRIS was built in 1996 with the idea actually to do some polarization and also a diffraction, but it was supposed to also be a little bit better than IRIS and complement it. So it took first neutrons in 1998, only in the diffraction mode, so it has a big diffraction bank, and spectroscopy started in about 2002. Again, today, like IRIS, it does a lot of productive science. It has higher flux, a little bit worse resolution, but only slightly. In 2023, we hope to install a silicon analyzer, so be able to increase the resolution. And it will be its 25th birthday. And then in the future, as part of our newest ICES upgrade program called Endeavour, we intend to upgrade the guide on OSIRIS to gain even more flux to give it another boost. And then in parallel, when TS2 was built, there was so these are all obviously both IRIS and OSIRIS are indirect geometry spectrometers. In parallel, when TS2 was built in 2007, the second target station, there was a direct geometry machine, more like IM5 at the ILL or CNCS at SNS, LET. And primarily it was used by the magnetism community. It in fact organizationally belongs to not the molecular spectroscopy group, but the excitations group. So QUENS only forms a small part of it, but with the advent of rep rate multiplication capabilities on LET, it became very interesting for the QUENS community. It published its first QUENS experiment on lipid membranes actually in 2015, owing to the fact that LET has position sensitive detectors. So it was really good to look at in-plane and out-of-plane diffusion in lipid membranes. And then polarization started growing at ICES, and polarized neutrons and LET pretty much started in 2019, which led to the first PLET. So this is polarized LET publication in 2019. So that's a little bit to put it in perspective. And I'm not going to go through this, but the concept of sort of polarization has been around almost since the beginning of IRIS and OSIRIS. It went, it was talked about in putting it in IRIS and OSIRIS, and due to different things that happened over the years, it was never actually materialized on the inverted geometry machines. But thankfully, it's on LET, which is obviously the direct geometry. So now we have kind of taken timely advantage of where we are at ICES with polarization, with QUENS, and we need to really rethink our options for the future. So we need to think really our options for the future for IRIS, because it's an aging instrument, even though it's still very productive. But we also had the recent creation of a dedicated instrumentation group, which is headed by Rob, and the polarization expertise lies within this group. So there's clearly increased resourcing in polarization analysis staff in ICES, and so it's a good time to take advantage of this. It's clear that QUENS measurements with polarization on direct geometry spectrometers have now been demonstrated. They've demonstrated the benefits of polarization to separate incoherent to coherent, and hopefully we'll hear a little bit about that today. But indirect geometry instruments on spallation sources have benefits in terms of cost, sensitivity, resolution, and simplicity. And currently, there are no working instruments with polarization and inverted geometry style. So this is why we're quite keen on exploring this, this area. There's also been, especially in-house, Rob, this concept, new concepts coming up, technical concepts that allow us to get significant increases in signals. So this also, we will take this to our advantage in exploring the technical design of an instrument such as SHERPA. In the context of what we're doing for the future, as I said, we're filling the OSIRIS empty side with a silicon analyzer, which would give us a higher resolution of around 11 microelectron volts, and we're replacing the guide. And, you know, there are still empty ports in our second target station. So all in all, this seems like a good time to really take this seriously. So what you'll be hearing is about a proposition of an near backscattering instrument, so inverted geometry at a spallation source instrument with single axis polarization probably, and similar Q and omega coverage that is needed by the quens community. And we should say that we're in the very early stages, and this is why we really want your input here.